Hi everyone and welcome to our video demonstration for BITS1213 operating system project. Our project is titled Phantom Leak Protocol Secure Quarantine Zone Implementation. This project was complete for semester 2 under the guidance of Dr. Febrian Rusdi here at UTeM. In this video, our group will be walking you through the complete setup of our private virtual network. We will demonstrate you the complete configuration for each service and prove that our network is fully functional and perfectly isolated. My name is AIMAN and I will be kicking off things today.
Hi, I'm ALLYSSA and I will be walking you through our group's network setup for the Phantom Leak Protocol. Our topology consists of a Linux server and a Linux client connected via a private internal network. The server acts as a gateway, bridging internet access via NAT on ETH1, while all our services are strictly bound to the internal interface ETH2 using the IP address 192.168.1.254. To implement this, we configured both virtual machines within VirtualBox settings. On the server VM, we enabled adapter 1 for NAT to allow for package installations. We then enabled adapter 2, attached it to an internal network named INT-NET, and set it to allow all for promiscuous mode. On the client VM, we configured a single adapter 1, attached it to the same internal network named INT-NET. It is critical that both machines use the same exact network name, or they will not be able to communicate. Now, let's verify our implementation. We perform a ping test from the client VM to the server's internal IP address 192.168.1.254. As you can see, the connection is successful, confirming our internal network is functional. Next, we verify the quarantine isolation by pinging 8.8.8.8. The output, network is unreachable, confirms that the client has no internet access, effectively proving the secure quarantine zone is correctly implemented. With the network infrastructure verified and isolation confirmed, I will now demonstrate the configuration and testing of our DHCP and web services. Following that, my partner will demonstrate the SFTP and database server configurations. Let's begin with the DHCP service.
Hi everyone, I'm ALLYSSA and I'll be walking you through the configuration and testing of our DHCP server.
The DHCP server's role is to automatically assign IP addresses, but it must be restricted strictly to our internal network. First, I edited the interface settings by typing sudo nano /etc/etc/isc-dhcp-server to serve only ETH2. It is critical not to put ETH1 here, otherwise the server would lose its internet connection.
Next, in the /etc/dhcp/dhcpd.conf file, I defined our subnet. I set the IP allocation range from 192.168.1.5 to 192.168.1.10. Most importantly, I included the directive option routers 192.168.1.254. Without this, the client wouldn't be able to communicate with the server at all. Now, for the testing phase, over on the client machine, I will run sudo dh client space eth1 to request an IP, followed by IP space a space show space eth1 to verify. As you can see, the client successfully pulled an IP within our designated range. To prove our quarantine zone is completely isolated, I will attempt to ping the outside world using ping space 8.8.8.8 space dash C space 2. The output returns network is unreachable, which is the exact correct behavior to confirm the client has zero internet access.
Now I will demonstrate our secure SFTP service, which use OpenSSH to ensure encrypted file transfer. First, I install the OpenSSH server and create a dedicated username named researcher. I then configure the SSH daemon /etc/ssh/sshd underscore config to listen to specifically on our internal IP, which is 192.168.1.254. I also implemented a sysroot directory directive to log the user within their own directory, ensuring they cannot access the rest of our server's file system. After restarting the service, I verified the port binding with SS-TLNP to ensure it's only accessible from our internal network. To test this, I switched to the client VM and successfully connected to using SFTP researcher at 192.168.1.254. I confirmed that I could upload a test file to the remote directory and the system correctly isolate the session to the researcher's home folder, confirming that our security restrictions are working perfectly.
Hi everyone, I'm ALLYSSA again, and I will be demonstrating the configuration and testing for our internal web server, which hosts our secure company portal. First, we utilize Apache 2 for this service. I installed it on the Linux server by running sudo apt install apache 2 -y. To enforce our strict isolation requirements, the server must not be accessible externally. I open the configuration file by typing sudo nano /etc/apache2/ports.conf. Here, I modified the settings so that the server listens exclusively on our internal gateway. Listen space 192.168.1.254:80. I then updated the default virtual host configuration by opening /etc/sites-available/000-default.conf. I changed the header to match our strict IP requirement, typing virtual host space 192.168.1.254:80. Next, I created our custom internal portal page in /var/www/html/index.html as noted in my report. I assumed it was the best practice to completely override the default Apache page with our custom HTML to ensure no legacy files remained. I restarted the service with sudo systemctl restart apache 2 to verify the binding was successful. I ran sudo ss space -tlnp space pipe space grep space :80. The output confirms this service is listening strictly on our internal IP. Finally, to test the portal's isolation, I switched to the Linux client VM. I executed the command wget space -q O space http://192.168.1.254. As you can see, the terminal successfully returns our custom HTML content, proving the client can seamlessly and securely access the internal portal.
Finally,
For our data management, I configure the MariaDB database server. After installation MariaDB, I ran the secure installation script to harden the database instance. I then configure the bind address in the server configuration file to 192.168.1.254 to ensure the database only accepts internal connection. I create a dedicated database plate named phantom and restricted user, external user, with privilege specifically tied to our internal network range. Finally, I verify the connection from the client virtual machine, confirming we can successfully query our sensitive _data table.
And that brings us to the end of our demonstration. To quickly summarize, our group has successfully built the quarantine zone and complete all 4 required services, which is the DHCP, SFTP, the web server, and the database server.
Most importantly, as you saw in our testing, we have confirmed that every single service is strictly bound to our internal IP address 192.168.1.254. We also verified that the client machine has absolutely no internet access, satisfying the critical requirement for complete client isolation.
We have successfully met all the criteria outlined in the Phantom Link protocol.
Thank you, Dr. Jack, and to our peer assessors for watching our presentation. Have a great day.